Welcome dear friend, welcome again to my channel Talking Physics with Piyas Sarkar. So we shall learn anything interesting today. Okay, previous day we shall learn about the nuclear binding energy, mass defect and many other things. You can show it in my channel, and today we shall learn about the radioactivity phenomena, the basic or introduction to radioactivity. If I asked you a question that why hydrogen or oxygen is stable but uranium, rubidium or another particles is unstable, thorium, uranium, rubidium, polonium, thorium, why these are unstable? This is the basic question. Can you answer it? If you know the answer, comment, please write in my comment box, or if you don't know the answer, please watch my channel. Okay. So at first we go with the cause of instability, that why an atom or nucleus is stable or not. Now, for lighter stable nuclei, the ratio of neutron to proton is equal to 1. That is, for lighter nucleus, neutron value is almost equal to proton value. If we saw the graph, here is neutron number, and along y-axis if you take the proton number, we get a stability curve like this. So in which the neutron and proton number must be equal, the nuclei is stable. That is, if we take the example of 1H2, that is deuterium, here the ratio of neutron by proton is 1, because neutron is 1, proton is 1. If we take the answer of oxygen or helium, 2He4, then again here neutron by proton ratio is 1. So for lighter nuclei, the value of neutron and proton is equal to 1, lies in the near of stability curve. But for heavier nuclei, this number, that is neutron by proton ratio, is increased, as due to increase in mass number, the number of neutron is increased and number of proton is also increased. So for the heaviest stable nuclei, for heaviest stable, not unstable, for heaviest stable nuclei, it is, that is the ratio of neutron to proton ratio is nearly equal to 1.6. So for heavier nuclei, the proton value is greater, is increases, and due to increase in proton, there is also increase the repulsion force acting along them. So due to this repulsing force, that is the proton are always tends to repel with other, and the nucleus becomes unstable. So all the heavier nuclei tends to get the number of neutrons is large than proton, because neutron does not take part in Coulomb repulsion force. So when the proton number is large, then a proton is captured an electron, suppose this is k cell electron, in most of the case it is k cell electron, and in transferred into neutron, and a new particle called neutrino, antineutrino is produced. Sorry, here the neutrino is produced. A new particle neutrino is produced, not neutron, neutrino. Okay, neutron, this is neutron and this is neutrino. So the proton becomes capturing a K cell electron, transferring to neutron and becomes steady the nucleus. This process is called electron capture or as it is K cell electron, so it is also called K capture process. K capture process. So for heavier nucleus, when a proton transfers it into a neutron, it becomes stable. But there is also a inconvenience in it, because if the neutron number is so large, then it becomes, if the neutron number is much larger than proton, then it becomes also unstable, because there is no neutron proton pair occurred and the atom has large binding energy and it split into lighter particle or it becomes unstable. So if the proton number is, in a words, we can say that if the proton number is very large or the neutron number is very large, the nucleus becomes stable, and the neutron by proton ratio for lighter nuclei is 1, and for heavier nucleus it becomes 1.5 to 1.6, it becomes stable, otherwise it becomes unstable. Also one thing is, we should mind that there will be nuclei with neutron number equal to even and proton number is equal to even is more stable, about 60% atom shows this property, neutron even, proton number even. But if neutron number is odd, proton number is odd, it becomes unstable. There is some exception in it. 1H1, lithium, hydrogen, lithium, boron and nitrogen. This has odd numbers of Z value, that is atomic number or proton number. In spite of this is stable. This is an exceptional case. Otherwise, the all case, when the proton number is odd or neutron number is odd, it becomes unstable. So we now know the reason of stability and instability factor. Now we go with the what happens if the nucleus becomes unstable. So when a nucleus becomes unstable, it quickly transferred spontaneously into a new nucleus. Suppose nucleus A is unstable, then it transfer into another new nucleus, nucleus B. But this emission is spontaneous. We cannot initiate it. It is a spontaneous process. We cannot stop it or cannot initiate it. But A and B, the A is called parent nucleus, and B is called daughter, not son. Okay, daughter nucleus. But here some penetrating rays are emitted from parent nucleus. Suppose it will be alpha rays, or it will be beta rays, or gamma rays. These three types of rays will emit, and a nucleus is spontaneously transformed into another new nucleus, which is, the process is called radioactivity. So what is the definition of radioactivity? So the definition of radioactivity is the process of disintegration means transformations. The process of disintegrations of a nucleus of an atom into a new nucleus spontaneously with emission of some penetrating rays called alpha, beta or gamma is known as radioactivity. Okay, this is the definition of radioactivity. The process of disintegration of a nucleus of an atom into a new nucleus spontaneously, you must be write this word spontaneously, with emission of some penetrating rays is known as radioactivity, and these rays are called radioactivity rays, and this the element that is the parent nucleus is called a radioactive substance, is called radioactive substance. Okay. So now we go with the history of radioactivity. It is not very necessary in your exam, but you must have to know it. It is a very funny story or interesting story. A French scientist called named Henri Becquerel. Henri Becquerel. It is a French scientist. French scientist Henri Becquerel in the year of 1896. He placed a substance wrapped in a paper. This is potassium or uranium potassium sulfate. This substance is uranium potassium sulfate. Okay, wrapped in a paper, put in a drawer, and there is a photographic plate which is isolated by the uranium potassium sulfate by a silver foil or silver paper. After few hours, when he opened the drawer, he saw that there is blackening in the photographic plate. He astonished, become surprised, and thought and was eager to find the reason. Soon he found that this blackening is due to the emission of some infrared rays from this uranium compound. So he then says the name of this rays is Becquerel. This is called Becquerel rays. Okay. So then he named this rays as Becquerel rays. Then a couple of years later, two famous scientists who were husband and wife in relation, whose name was Pierre Curie and Marie Curie, isolated or invented two more compound. One is polonium, another is rubidium. And he found that these were 10 to the power 6 times, million times more radioactive than uranium. Then they name these substances as radioactive substances, and the process is called radioactivity. In general, if the proton number or atomic number is greater than 82, then all the elements are radioactive. The most stable nucleus with mass number 83, that is Bismuth 83209, mass number is 209, atomic number 83, is heaviest stable nucleus, and after this all the nucleus becomes radioactive. Okay, so this is the small history of finding out the phenomena of radioactivity. Now we shall go with some small introduction of radioactive rays, which is alpha, beta and gamma rays, you know. So if we take a chart, please put your exercise book and your pen and note down this chart so that you can easily memorize it. So if we take a column that alpha, beta and gamma, we take at first the nature. What is the nature of alpha ray? What is the nature of beta ray? And what is the nature of gamma ray? Alpha ray is nothing but helium nucleus. Helium nucleus. Beta ray is nothing but electron with nuclear origin. We shall discuss it in our next video, that beta ray is obviously an electron, but it is not the orbital electron. Okay, it comes from nucleus. Nucleus is not its constituent as electron, because there is only two constituent we know, that is the proton and neutron. In spite of this, beta ray coming from nucleus. Why? We can say it later, says it in our next video. Please subscribe my channel. And number 3 is gamma ray is an high energy electromagnetic radiation. High energy EM, that is electromagnetic radiation. Number 2 is charge, number 2 is mass. Mass is 6.67 into 10 to the power minus 27 kg or plus 4 AMU. 9.1 into 10 to the power minus 31 kg, that is equal to mass of an electron. Rest mass 0, not mass 0, rest mass 0. I shall talk it in my previous picture, that is there is two type of mass, when the particle is rest and when it is moving with velocity of light, and if the moving, then there is a moving mass, and if stop, then it is the rest mass. Number 3 is charge. So the charge of alpha particle is plus 2e, that is 2 into charge of electron 1.6 into 10 to the power minus 19 coulomb. Charge of electron is beta particle is E, and charge of gamma is 0. Number 4 is deflection. Alpha particle deflected towards positive plate. Beta particle deflected towards negative plate, and gamma particle shows no deflection. Again deflection. Number 5 is ionizing power. Ionizing power is alpha particle is maximum. It is about 10 to the power 4 times gamma rays, this is 100 times, that is 10 to the power 2 times gamma rays, and its ionization power is minimum. Number 6 is penetrating power. Penetrating. This is reverse, that is alpha particle penetrating power is minimum, beta particle is 10 square times than gamma rays, and gamma rays penetrating power is 10 to the power 4 times of alpha rays. Number 7 is fluorescence on ZNS phosphor or photographic plate. It has strong effect on photographic plate or ZNS, but it has less effect, and also it has less effect. So this is basically some small introduction of alpha particle, beta particle and gamma particle. Please note down in your copy. Now we shall go with some law related to radioactivity. In the next day we shall go with radioactive decay law and the total derivation of mean life, average life and any other relation and some numericals related to it. So in any nuclear reaction there will be two quantity which may be conserved. One is charge and one is mass number. According to sodi and Rutherford, the charge is conserved, must be conserved before and after disintegration. Number 2, mass number is conserved for initial and final particle. On the basis of these two laws, sodi and fajans gives three very interesting law related to alpha, beta and gamma particles. Alpha, beta and gamma particles. One is if a radioactive nuclei emits alpha particle, its proton number decreased by 2 and mass number is decreased by 4. As alpha particle is helium, helium has 2 proton and 4 mass number, so mass number is reduced by 4 and proton number is reduced by 2. Number 2, if a radioactive nuclei emits beta particle, its atomic number or proton number, atomic number is increased, not decreased, increased by +1 and mass number is unchanged. Number 3, if a radioactive nuclei emits gamma particle, its mass number and atomic number is unchanged. So these 3 rules are known as sodi and fajan's rule of radioactivity. If we said to in your exam that what is sodi and fajan's rules, these 3 rule is sodi and fajan's rule. So we give an example so that you can relate it. Okay, suppose a radioactive sample is A and it emits an alpha particle. The new nucleus is A1. It also emits an beta particle which gives a new nucleus A2, then emits an alpha particle which gives nucleus A3 and then gamma particle A4. If A has atomic number 72 and mass number 180, what will be the Z and A, that is the mass number and atomic number of A4. So according to Sodi-Fajan's rule, if alpha particle emits, then it is 70 minus 2 atomic number, that is 70, and the mass number is decreased by 4, that is 180 minus 4, that is 176. Now beta particle mass number unchanged and atomic number is increased by 1, that is 71. Then again alpha particle emits, then it is decreased by 2, that is 69, and it is decreased by 2, that is 172. And gamma particle is the mass number and proton number is unchanged, that is it is equal to 176, 71. Okay, beta particle the mass number is unchanged, again alpha particle that is the mass number is decreased 2 and 4, 170, and gamma particle then is mass number is unchanged and also the proton number is unchanged, but its energy is increased because beta particle emission is always accompanied by gamma rays, because when a beta particle emits from a nucleus, the nucleus, suppose this is ground state and it is excited state, the nucleus is acquires more energy and come to the excited state, but the limitation of remaining in excited state is 10 to the power minus 8 second or late or little, so it again comes to the ground state and emits a gamma ray particle. So if a nucleus cannot excite to the excited state, cannot emit a gamma ray state. This is the reason, because the gamma rays does not comes first but always comes after emission of alpha or beta particles. So this is the basic theory of radioactivity. I hope this will help you a lot. In the next season or next video, we shall go with the radioactive decay law, the mean life, average life, and its numericals. If you like my channel, please press the bell icon and subscribe for such new interesting video. Thank you.